Hello, welcome to Moja Life. Today, we will discuss the Parkland formula. But first, take 5 seconds to subscribe to our channel and turn on the notification bell for more educative videos. 1, 2, 3, 4, 5. Thank you. Let's get started. Burn injuries are one of the most devastating injuries that can happen to a person, and they require specialized care. Parkland formula is one of the crucial parts of the treatment process for burn patients. The Parkland formula is a mathematical formula used to calculate the amount of fluid that a burn patient needs in the first 24 hours following injury. The formula takes into account the patient's weight and the total body surface area affected by burn. Before we dive into Parkland formula, let's discuss the rule of 9. The rule of 9 is an easy and quick method of estimating the percentage of the total body surface area affected by burn. The rule of 9 divides the body into regions that each represent 9% of the body's surface area. Here are the sections of the rule of 9. 4.5% for anterior surface of head and neck. 4.5% for posterior surface of head and neck. 4.5% for anterior surface of each upper limb. 4.5% for posterior surface of each upper limb. 18% for anterior surface of the trunk. 18% for posterior surface of the trunk. 9% for anterior surface of each lower limb. 9% for posterior surface of each lower limb. 1% for perineum. These makes a total of 100%. Knowing the rule of 9 is a key step in calculating the amounts of fluids a burn patient requires in the first 24 hours using the Parkland formula. Now, let's discuss the Parkland formula itself. Again, the Parkland formula is a calculation used to determine the amounts of fluids a burn patient requires in the first 24 hours following injury. The formula takes into account the patient's weight in kilograms and the percentage of the total body surface area burnt. Remember, weight is always in kilogram. So, if you are given the weight in pound, then you must convert it into kilogram. Understanding the rule of 9, as discussed above, will help you to easily estimate the percentage of the total body surface area affected by burn. Therefore, the total fluid requirements for a burn patient in the first 24 hours, using the Parkland formula, is calculated as follows. 4 ml times the patient weight in kilogram times the percentage of the total body surface area affected by burn. For example, if the patient weighs 70 kg and has 20% of their body surface area affected by a burn, the formula would be 4 ml times 70 kg times 20%, which means the patient will be given 5,600 ml in the first 24 hours. However, fluid replacement in burn patient is done in 2 parts. Half of the total fluid requirement is given in the first 8 hours, while the remaining half is given in the next 24 hours. For example, if the total fluid required in the first 24 hours is 5,600 ml, it means half of the fluid, that is, 2,800 ml, will be given in the first 8 hours, while the remaining half, 2,800 ml, in the next 16 hours. Here is another example to help you better understand how fluid replacement is done in the first 24 hours. A 50-year-old male patient has a partial thickness burn on the posterior head and neck, anterior and posterior surfaces of the right and left arm, anterior trunk, front surfaces of both lower limbs. If the patient weighs 80 kilograms, how much lactated ringers are you going to give in the next 24 hours? Also, how much intravenous fluid per hour are you giving in the first 8 hours and the next 16 hours? You can pause the video for 2 minutes to respond to this question. Are you done? Good. Let's work it out together. Using the Parkland formula, the total fluid requirements for a burn patient in the first 24 hours is equal to 4 ml times weight in kilogram times the percentage of the total body surface area affected by burn. From the question above, we are given weight as 80 kilograms, but we don't know the percentage of the total body surface area affected by burn. That is where we have to apply the rule of 9. Let's start by listing the parts of the body affected by burn. Posterior head and neck, which represents 4.5%. Anterior and posterior surfaces of the right and left arm, which both represents 18%. Anterior trunk, which represents 18%. And lastly, front surfaces of both lower limbs, which both represents 18%. So, the percentage of the total body surface area affected by burn is equal to 4.5 plus 18 plus 18 plus 18, that is equivalent to 58.5%. Now, we can answer the first part of the question. The amounts of lactated ringers going to be given in the next 24 hours can be calculated using the Parkland formula, that is, 4 ml times 80 kg times 58.5%. which is equivalent to 18,720 ml. Did you get the same answer? Wonderful. Now, let's answer part 2 of the question. How much intravenous fluid per hour are you giving in the first 8 hours? Again, note the catch in this question. They need the amount of fluid per hour to be given in the first 8 hours. Remember, in burn patient, fluid replacement in the first 24 hours is done in 2 parts, half in the first 8 hours, and remaining half in the next 16 hours. Therefore, in the first 8 hours, the amount of fluid to be given is calculated by taking 18,720 ml then dividing it by 2, which is equal to 9,360 ml. Therefore, to get the amount of fluids to be given per hour in the first 8 hours, take 9,360 and divide by 8, which is equivalent to 1,170 ml per hour. Did you get the answer correct? Great! Having answered the second part of the question, the last part become even easier. How much intravenous fluid per hour are you giving in the next 16 hours? Again, in burn patient, fluid replacement in the first 24 hours is done in 2 parts, half in the first 8 hours, and remaining half in the next 16 hours. We have already known that the total fluid required in the first 24 hours is 18,270 ml, thus, half the fluid to be given in the next 16 hours is equal to 9,360 ml, right? However, we are required to calculate the amount of fluid per hour to be given in the next 16 hours. Therefore, take 9,360 ml divide by 16, which is equivalent to 585 ml. Did you get the correct answer? Type yes in the comments section below. We have come to the end of our video. If you found this video helpful, please subscribe to our channel and turn on the notification bell for more informative videos.